Close your eyes and imagine. You're standing at the edge of an enormous canyon, looking down at layers of rock descending into the abyss. Each layer is a page in the book of time. Red clay, gray limestone, black shale. Millions of years compressed into a few meters of stone. And somewhere there, in the deepest layers, a truth might be hiding that could overturn everything we know about ourselves. The truth that we may not be the first. All our lives we've been told a simple story. First, there was an empty planet. Then life appeared, simple, primitive. Millions of years of evolution, dinosaurs, their extinction, and finally, us. Homo sapiens, the first and only civilization Earth has ever known. We build cities, write books, fly into space. We are nature's crowning achievement, the final chapter in the story of intelligence on this planet. But what if that's not true? What if our story is only the last chapter in a book containing thousands of chapters? What if others came before us? Not just animals, not just instinctive creatures, but intelligent species that also built, thought, created. And what if they vanished so long ago that almost nothing remains of them? It sounds like science fiction, doesn't it? But think for a moment. Earth is 4.5 billion years old. 4,500 million years. Try to imagine that number. Can't do it? That's normal. Our brains aren't equipped to comprehend such spans of time. We live 70, maybe 80 years if we're lucky. Even 1,000 years seems like eternity to us. But 1,000,000 years? 1,000,000,000 years? That's beyond our understanding. Let's try another way. Imagine all of Earth's history compressed into one calendar year. January 1st, at exactly midnight, our planet forms. A molten ball of rock spinning in the darkness of space. The first weeks are hell, literally. The surface boils, asteroids bombard the young world. Everything around is fire and destruction. Somewhere in late January, early February, the planet begins to cool. A solid crust forms. Rains fall, not ordinary rains, but torrents of water lasting thousands of years, filling depressions, creating the first oceans. And there, in the warm waters of ancient seas, somewhere in March, the first life appears. Tiny bacteria so simple they can barely be called alive. But they exist, and this is the beginning. Months pass. Life remains simple. Single-celled organisms that slowly, very slowly evolve. April, May, June, July, August. 8 months during which almost nothing changes. If you could look at Earth during these months, you would see only water and rocks. No plants, no animals. Just endless oceans full of invisible microscopic life. Only in September does something interesting begin. The first multicellular organisms appear. Strange creatures unlike anything modern. They swim, crawl along the ocean floor, filter water searching for food. By the end of September, life explodes with diversity. This is what scientists call the Cambrian explosion, a sudden appearance of multitudes of new life forms. October brings the first plants to land. Green patches begin covering the previously barren continents. Insects appear. Giant millipedes crawl among ancient ferns. In November, dinosaurs appear. These incredible creatures will rule the planet for nearly 2 months by our compressed calendar. Imagine it. 2 full months of reptilian dominance. And then comes December 26th. Suddenly, in one moment, an asteroid slams into Earth. The sky darkens, temperature plummets, dinosaurs die out. Most life on the planet vanishes. But not all. Small, furry creatures survive, mammals. They were here all along, hiding in the shadows of giants. Now, their time has come. December 27th, 28th, 29th. Mammals spread, evolve, occupy empty niches. And only on December 31st, on the very last day of the year, we appear. The first ape-like primates emerge around noon. Homo sapiens, our species, appears only at 11:37 p.m., 23 minutes before midnight. And everything we call civilization, The Egyptian pyramids, the Roman Empire, the Middle Ages, the Industrial Revolution, the Internet. All of this happens in the last 11 seconds of the year. 11 seconds. All of recorded human history fits into the time it takes you to count from 1 to 11. Now, holding this picture in your mind, ask yourself a question. What was happening during the other 364 days, 23 hours, 59 minutes, and 49 seconds? We're so certain we know the answer. We're so certain that during all this unimaginable time, intelligence arose only once. Only in us. Only in these last moments. Think about how evolution works. It doesn't invent something once and stop. It experiments again and again. Eyes, for example. Evolution independently created eyes at least 40 times. Insects have one kind of eyes, we have another, octopuses have a third. And they all developed separately because seeing is useful for survival. Wings appeared again and again. In insects, in birds, in bats, even in ancient reptiles. Each time nature found a new solution to the problem of flight. So why should intelligence be the exception? Why do we assume that the ability to think, to plan, to create is something so unique that it appeared only once in the entire history of the planet? Doesn't that seem improbable? Imagine a planet 100 million years ago. Dinosaurs are still here. They've already ruled Earth for more than 50 million years by this point. Among them are remarkable creatures. Troodon, for instance, a small dinosaur with an unusually large brain for its size. It hunted in packs, used coordinated tactics. Some paleontologists think that if dinosaurs hadn't died out, Troodon or its descendants might have developed higher intelligence. But let's go further back. 200 million years ago. 300 million. In each of these epochs, thousands, tens of thousands of different species lived. And each species had the opportunity to evolve toward greater intelligence if it provided a survival advantage. Over 300 million years, there could have been dozens, hundreds of nature's attempts to create intelligence. And here we come to the most difficult question. If they existed, these other intelligent species, where are their traces? Where are the cities? Where are the tools? Where is anything that would tell us, yes, there was a civilization here? The answer lies in understanding what time means on a geological scale. Time is the greatest destroyer that exists. It erases everything slowly, patiently, inexorably. Take our modern world as an example. Imagine that tomorrow, right now, all of humanity disappears, simply vanishes as if we never existed. What will happen to our cities? The first year won't seem so dramatic. Buildings stand, roads remain in place, cars rust but are still recognizable. Plants begin breaking through cracks in the asphalt. Without people to mow lawns and pull weeds, nature starts returning. After 10 years, the picture changes dramatically. Roofs leak, water penetrates buildings. Freeze-thaw cycles destroy concrete. Trees grow straight out of windows. Metal structures corrode. Cities begin to resemble ruins. After 100 years, most wooden structures have rotted. Most metal structures have rusted and collapsed. Glass skyscrapers, these symbols of modern civilization, lie in piles of shards. Forests cover territories that were once cities. Animals return, inhabiting spaces from which humans once displaced them. 1,000 years, and almost nothing remains above the surface. Maybe here and there remnants of stone foundations stick out. Maybe somewhere in deserts or deep caves some artifacts are preserved, but mostly nothing. Nature has swallowed everything. 10,000 years, and even these last traces begin disappearing under the action of wind, water, vegetation, freeze-thaw cycles, chemical processes. Stone crumbles, turns to sand. Metal oxidizes, becomes part of the soil. 100,000 years, and from our civilization, only the most indestructible materials remain in the most protected places. Yes, some plastics may survive. Yes, Somewhere deep underground, metal objects may lie, transformed into strange mineral formations. But someone studying Earth 100,000 years from now won't find cities. They won't find obvious signs that a civilization was here 1,000,000 years. And even these last traces become almost indistinguishable. Plastic has broken down into molecules. Concrete has crumbled to dust. Metals have mixed with natural ores. What remains? A thin layer in the geological record where the concentration of certain elements is slightly unusual, where the chemical composition of soil shows a strange anomaly, where carbon isotopes behave not quite as expected. A geologist of the future studying this layer might notice something strange, but will they understand what it means? Or will they simply attribute the anomaly to some natural phenomenon? An unusual volcanic eruption, a rare meteor shower, a strange climatic cycle. And now let's add more time. Not 1,000,000 years, but 10, 50, 100. During this time, the continents themselves will change. Mountains that stood when our civilization existed will be worn away by erosion. New mountains will rise in their place. Oceans will open and close. Tectonic plates will shift, plunging entire regions into Earth's mantle, where they'll melt and become part of volcanic activity elsewhere on the planet. After 100 million years, absolutely nothing will remain of our civilization that could be found by chance. No ruins, no artifacts, no obvious signs. Only very subtle, very specific chemical and geological anomalies that one would need to search for purposefully, knowing what to look for. And here, the true depth of the problem reveals itself. If we, with our advanced technology, with our skyscrapers and nuclear reactors, with our plastics and alloys, will leave such a faint trace after 100 million years, how can we expect to find traces of a civilization that existed 200 million years ago? Or 300? Or more? Perhaps they existed. Perhaps civilizations have already risen and fallen on Earth that we'll never know about. Not because they didn't exist, but because time is too good at keeping secrets. There's one thing that makes this possibility even more real. We think of civilization in very specific terms. We imagine cities of stone and metal, machines, electricity, computers. But this is our path. The path of primates with grasping limbs and binocular vision. What if another civilization took a completely different path? Imagine an intelligent species that evolved in the ocean. Dolphins, for instance, already demonstrate complex social behavior, capacity for learning, even rudiments of culture. What if somewhere in the past an oceanic species developed true intelligence? They wouldn't build buildings, in water that's meaningless. They wouldn't light fires. Underwater, that's impossible. Their technology, if it existed, would be completely different. Perhaps biotechnology, using living organisms to create tools. Perhaps something we can't even imagine. Such a civilization would leave even fewer traces than ours. And if it existed in an ocean that later disappeared due to continental movement, all its traces would be buried under mountain ranges or destroyed by subduction, the process by which ocean floor is pulled back into Earth's mantle. Or imagine a civilization that lived in harmony with its environment. Not industrial, not expansive, but sustainable. They used renewable resources, didn't pollute the atmosphere, didn't mine metals in huge quantities. Such a civilization could exist for millions of years without leaving the crude geological imprint we're leaving. We see the world through the lens of our own experience. We think civilization must look like ours. But this is anthropocentric delusion. Intelligence can take forms we can't even imagine, and these forms may leave traces we don't know how to recognize. The silence of night surrounds you. Stars slowly move across the sky, following their ancient paths. And in this silence, it's easy to feel the weight of time. Not the time we measure with clocks and calendars, but that deep geological time that flows at the speed of mountain ranges and continental drift. In 2018, two scientists published an unusual scientific paper. Gavin Schmidt, a climatologist at NASA, and Adam Frank, an astrophysicist from the University of Rochester, asked a question that sounded almost like science fiction, but had serious scientific foundation. They asked, if an industrial civilization existed on Earth millions of years ago, could we detect its traces? They called it the Silurian hypothesis, a reference to a species of intelligent reptiles from a British science fiction series. But behind the playful name lay a serious thought experiment. The scientists weren't claiming such a civilization existed. They were asking a methodological question. What would the evidence look like if it had? Their conclusions were simultaneously fascinating and troubling. Even our own civilization, which has so radically changed the planet, might become almost invisible in the geological record given enough time. Yes, we leave traces. Plastic in the oceans, altered atmospheric composition, radioactive isotopes from nuclear tests. But how long will these traces last? Plastic degrades, slowly, but it degrades. After millions of years, most of it will turn into scattered organic molecules. Changes in the atmosphere will smooth out over time through natural processes. Radioactive isotopes will decay. What will remain? Perhaps the most lasting trace will be changes in the isotopic composition of carbon. When we burn fossil fuels, coal, oil, gas, we release into the atmosphere carbon that was buried millions of years ago. This ancient carbon has a slightly different ratio of isotopes compared to carbon circulating in the biosphere now. A sharp change in this ratio will leave a mark in geological layers. If a future geologist millions of years later studies rock samples from our era, they might notice this anomaly. A sudden spike in a certain type of carbon. But what will they think about it? Will they recognize it as a sign of industrial civilization? Or will they attribute it to some natural phenomenon? A massive volcanic event? Release of methane from oceanic deposits? Something else? The problem is that nature also creates anomalies. 56 million years ago, an event occurred that scientists call the Paleocene-Eocene thermal maximum. The planet's temperature suddenly rose by 5 to 8 degrees Celsius over a very short period by geological standards. Carbon isotopes in rocks from that time show a sharp change. Something released a huge amount of carbon into the atmosphere. Most scientists think these were natural causes. Perhaps massive release of methane from oceanic sediments triggered by volcanic activity. But could it have been something else? Could it have been an industrial civilization burning fuel just as we do? Probably not. But we can't rule it out with absolute certainty because we have no other evidence to check. And this is the point of the Silurian hypothesis. It's not about whether they actually existed. It's about the fact that we can't be sure. Our methods of detecting civilization in the deep past are too imperfect. The geological record is too fragmented. Time has erased too much. This is a humbling thought. We're used to thinking of science as something that gives us definite answers. But sometimes science tells us we don't know. And more importantly, we may never know. Some questions lie beyond our ability to answer them, not because we're not smart enough, but because evidence simply doesn't preserve long enough. But let's play with this idea further. Suppose for a moment that they existed. Suppose that 100 million years ago, or 200, or 300, a civilization existed on Earth. Not human, of course. Something else. Perhaps descended from dinosaurs. Perhaps from something even more ancient. What would they have looked like? This is an impossible question, of course, but we can try to imagine. If they were descendants of dinosaurs, perhaps they were reptilian, walking upright with developed forelimbs for manipulating objects. Perhaps they had skin covered with scales, large eyes adapted for hunting. Perhaps they were cold-blooded, which would mean they depended on external temperature and preferred warm climates. Or maybe they were something completely different, some form of life that has no modern analogs. What if in Earth's history there were evolutionary experiments that never repeated again? Forms of organizing matter and energy that arose, thrived, and disappeared without leaving descendants. If they reached the level of civilization, they must have developed language, culture, technology. Maybe they learned to use fire. Or, if they were oceanic creatures, maybe they developed other ways of manipulating energy. Maybe they built cities. Not like ours, but structures that served similar purposes. Places for living, for exchange, for learning. Maybe they had science. They studied the stars just as we do. They wondered about the nature of reality. Maybe they had philosophy, art, literature. Maybe they knew joy and suffering, love and loss. Maybe they feared death and searched for meaning in their existence. And then, something went wrong. Maybe they faced the same problem we're facing now. Climate change, caused by their own activity. Maybe they exhausted their planet's resources. Maybe they warred with each other and those wars became too destructive. Or maybe it was just bad luck. An asteroid, a super eruption of a volcano, a pandemic against which they had no defense. They died. All of them. Down to the last one. And the world continued without them. Nature returned, filling the space they left. Their cities crumbled, their tools rusted, their books, if they had books, rotted away. Rains washed away, winds scattered, time buried everything. And millions of years later, we stand here not even suspecting they once existed. We look at layers of rock and see nothing unusual. We consider ourselves the first and only. We tell ourselves a story of continuous progress, from simple to complex, from bacteria to us, from unintelligent to intelligent, a straight line of ascent. But what if history isn't a line? What if it's a cycle? Rise, fall, oblivion, again and again. What if we're not the pinnacle, but simply another attempt? Not the finale of history, but one of many paragraphs in an infinitely long book. There's something simultaneously eerie and comforting in this thought. Eerie because it reminds us of our fragility. We're not eternal. Our civilization can disappear, and given enough time, not even a memory of it will remain. Future intelligent beings, if they appear, won't know we were here. But there's also comfort. It makes us part of something larger. We're not alone in time. Maybe others walked this path before us. Maybe they too looked at the stars and wondered. Maybe they too loved, created, dreamed. And though they're no more, the very fact that they might have existed somehow connects us with them across the chasm of millions of years. Oceans keep secrets better than land. This is a strange fact, but it's important for our story. More than 70% of Earth's surface is covered with water, and most of that water is very deep. The average depth of the ocean is about 4 kilometers. There are places where the floor descends 11 kilometers below the surface. We've explored these depths far less than you might expect. The pressure there is so enormous that special equipment is required just to survive. Light doesn't penetrate that deep, so there's eternal darkness. Temperature is close to freezing, despite the fact that in some places hot springs burst from the floor. If a civilization existed on a continent that was later flooded, its remains would now lie on the ocean floor, perhaps at a depth of several kilometers, covered with a thick layer of sediment. Would we find them? Unlikely. Even if we accidentally sailed right over them, our instruments might not notice anything unusual beneath the layers of mud and sand. But there's an even more interesting possibility. The ocean floor isn't static. It's constantly renewing through the process of plate tectonics. On the ocean floor, there are places called mid-ocean ridges, where new Earth's crust forms from rising magma. This crust slowly moves away from the ridge, traveling across the ocean floor at a speed of a few centimeters per year. Eventually, millions of years later, this oceanic crust reaches the edge of a continental plate. And here, something dramatic happens. The denser oceanic crust plunges beneath the lighter continental crust, being pulled back into Earth's mantle. This is called subduction, and it means the ocean floor is completely recycled every 200 million years or so. Think about the implications. This is one reason why searching for ancient civilizations is so difficult. Entire regions of the planet, huge areas of ocean floor, These are places where the past is literally erased, recycled, destroyed by geological processes. And there's another factor: sea level changes. During ice ages, when huge amounts of water are locked in ice sheets, sea level drops by 100 meters or more. Continental shelves are exposed, becoming land. During interglacial periods like now, ice melts and sea level rises. This means that the coastlines of the past were in completely different places. Places that are now submerged 100 meters underwater were land 20,000 years ago. And conversely, places that were once thriving coastal regions are now flooded. Why does this matter? Because civilizations love coastlines. We know this from our own history. Almost all great ancient cities were built near water, on the banks of rivers, seas, oceans. Water provides food, transportation routes, trade opportunities. If another civilization existed in the past, it's quite likely that its main centers were also on coastlines. But those coastlines are now underwater, and most of them have never been explored. We simply don't know what's down there. Maybe nothing. Probably nothing. But maybe something. Sometimes findings make us think. Not necessarily evidence, but hints, oddities, things that don't quite fit the familiar picture. Archaeologists and geologists periodically stumble upon something that raises questions. Take, for example, the structure off the coast of the Japanese island of Yonaguni. In the mid-1980s, divers discovered underwater a massive formation of stone. Terraces, steps, right angles, something resembling carved pathways. At first glance, it looks like ruins of an ancient city or temple. Some enthusiasts date it to 10,000 years or older, based on when sea level was lower and this area was land. But most geologists disagree. They point out that rock in this region is layered sandstone that naturally erodes along parallel lines, creating formations that can look artificial. Right angles, flat surfaces, even something resembling steps. All of this can be the result of erosion and geological processes. So what is it? Nature or ruin? Honestly, nobody knows for sure. There's no clear evidence of tool working, no artifacts found nearby. But the possibility of human intervention can't be completely ruled out either. Maybe it was a natural formation that ancient peoples slightly modified, adding steps or platforms. Maybe it's entirely a natural phenomenon. There's no answer. Similar mysteries exist in many places. Off the coast of India, in the Gulf of Khambat, sonar detected something resembling geometric structures on the seafloor. Some samples raised from there were dated to thousands of years ago. But again, evidence is unconvincing, and most scientists remain skeptical. There are reports of strange stone structures on the floor of the Mediterranean Sea, in the Caribbean, off the coasts of various continents. Some of them are probably natural. Some may be remnants of relatively recent human settlements flooded by rising sea level after the last ice age. But they remind us that oceans hide their secrets very well. And here's what's interesting. If we find it so difficult to detect traces of human activity from just a few thousand years ago, under a few dozen meters of water, how much harder would it be to find traces of a non-human civilization millions of years ago under kilometers of sediment? The answer is practically impossible. Without purposeful large-scale searches that nobody conducts because most scientists don't think there's anything to look for. But let's approach the question from another angle. Instead of looking for physical artifacts that almost certainly haven't survived, what if we search for other kinds of traces? More subtle, but potentially more lasting. Climatologists study ice cores. Long cylinders of ice extracted from ice sheets of Antarctica and Greenland. These ice columns contain bubbles of ancient air, trapped when snow fell and compressed into ice. By analyzing these bubbles, scientists can reconstruct the composition of the atmosphere in the past. How much carbon dioxide there was, what the temperature was, even what pollutants were present. The oldest ice cores go back 800,000 years. That's incredibly long by human standards. You can see cycles of ice ages, warming, cooling. You can see how the concentration of greenhouse gases changed naturally throughout these cycles. And then, in the most recent layers, you see something sharply different. A sudden spike in carbon dioxide and methane starting around the 19th century. The beginning of the Industrial Revolution. This is our trace. This is the signature of human civilization in the planet's atmosphere. If another civilization existed and burned fuel, it would leave a similar trace. But here's the problem. Ice doesn't preserve that long. 800,000 years is the maximum for ice cores. If a civilization existed 2 million years ago, or 10, or 50, no ice core from that time exists. The ice is too old. It would have been crushed by pressure, melted, or simply flowed into the ocean. But there are other kinds of records. Sediment cores from the ocean floor, for example. When organisms die in the ocean, their shells sink to the bottom and accumulate layer by layer, millimeter by millimeter, millennium by millennium. These layers contain chemical information about water temperature, about atmospheric composition, about the life that existed at the time. By analyzing oxygen isotopes in these shells, scientists can determine ocean temperature in the past. By analyzing carbon, they can learn about the carbon cycle. How much carbon was in the atmosphere, how much in the ocean, how quickly it circulated through the biosphere. And here we see interesting things. Earth's history is full of sudden climate changes, sharp warmings, sharp coolings, periods when the carbon cycle seems to have gone crazy, releasing huge amounts of greenhouse gases into the atmosphere. Most of these events have explanations. Volcanic eruptions of incredible scale called traps. Millions of cubic kilometers of lava erupting over thousands or millions of years. Release of methane from frozen deposits on the ocean floor triggered by warming or underwater landslides. Changes in ocean currents that redistribute heat across the planet. But could any of these events have been something else? When you see a sharp spike in carbon dioxide in the record 56 million years ago, are you sure it was a natural phenomenon? Or is there the slightest possibility that it was someone burning fuel, changing the atmosphere just as we're doing now? The problem is that distinguishing these two scenarios is practically impossible. We have no way to say this carbon dioxide came from volcanoes and that one came from coal burning by a civilization. Chemically, they're identical. The only way to know for sure would be to find other evidence of that very civilization that correlates with the climate event. But if such evidence doesn't exist, and it probably doesn't, we're stuck with uncertainty. Some scientists have proposed looking for specific chemical signatures. For instance, industrial production creates not only carbon dioxide, it creates pollutants, heavy metals, soot, various chemical compounds that don't occur in large concentrations in nature. If you look at sediment layers from our era, you'll find elevated concentrations of lead from burning leaded gasoline. You'll find plastic particles. You'll find radioactive isotopes from nuclear tests. Cesium-137, strontium-90, plutonium-239. These things don't exist in nature in significant quantities. They're unambiguous markers of technological activity. So, if an ancient civilization used nuclear energy or weapons, we might find traces of long-lived radioactive isotopes in rocks of the appropriate age. If they mined and processed metals on industrial scales, we might find unusual concentrations of these metals in sediments. The problem again is that these signals become weaker over time. Radioactive isotopes decay. Metals distribute, dilute, mix with natural deposits. After tens or hundreds of millions of years, even these markers might become indistinguishable from background noise. And then there's plastic. We produce an incredible amount of plastic, hundreds of millions of tons every year. Most of it eventually ends up in the environment. Microplastics are now found everywhere, in soil, in water, in air, even in our bodies. Plastic is very persistent. It doesn't degrade quickly like organic material. Some types of plastic can survive thousands, perhaps tens of thousands of years. Over time, it breaks down into smaller and smaller fragments, but it doesn't disappear completely. What will happen to this plastic after millions of years? Some research suggests it might become part of the geological record, a thin layer rich in carbon polymers, distinguishable by its chemical structure from natural organic materials. This would be a marker, a plastic layer that would indicate the presence of a technological civilization. But again, the question is, how long will this last? Plastic consists of hydrocarbon chains. Over time, under pressure and temperature, these chains can break down, rearrange. Maybe after 100 million years, the plastic layer will turn into simply a layer rich in certain hydrocarbons that will be difficult to distinguish from other organic deposits. We don't know. We haven't conducted the experiment. We haven't left plastic lying under layers of rock for millions of years to see what happens. We can only guess based on our understanding of chemistry and geology. And this brings us back to the central problem. We're searching for something we've never seen. We're trying to imagine what evidence looks like for something that may or may not be real. It's like searching for a needle in a haystack without knowing what the needle looks like, and not even being certain the needle is there. But there's one thing we can say with certainty. If we're not looking, we definitely won't find it. Absence of evidence can mean it doesn't exist, but it can also mean we haven't looked carefully enough. Silence returns. Stars continue their slow dance across the sky. Somewhere far away, an owl cries, hunting in the darkness. And you lie here thinking about deep time, about lost civilizations, about the possibility that we're not the first. There's a certain terror in this thought, but there's also strange beauty. The terror is that it reminds us of our ephemerality. Everything we build, everything we create, everything we love can disappear. Not just die, but vanish so completely that even memory of us won't remain. Future civilizations, if they appear, won't know our names. They won't know we were here. But the beauty is that it makes the present more precious. If everything is temporary, if everything ultimately disappears, then what we do now matters precisely because it's all we have. The moment, this fragile, beautiful present. And there's a connection through time. If others were here before us, if they too looked at these same stars, asked the same questions, we're connected to them through these questions, through wonder, through curiosity, through the attempt to understand. Even if we never learn about them, even if no proof is ever found, the very possibility of their existence means something. It tells us that intelligence isn't unique, that we're part of a broader process, a pattern that the universe creates again and again. Stars, planets, life, intelligence. Maybe it's a cycle. Maybe this is what the universe does. And if so, then we're not alone. Not in space where there may be other civilizations on other planets orbiting other stars, but also in time. Others who came before us on this very planet, and perhaps others who will come after us when we're gone. This is a thought that can comfort you as you fall asleep. You're part of a long line of intelligent beings trying to understand their world. Not the first, perhaps, and not the last, but real, here, now. And that matters. There exists a strange concept in geology called the stratigraphic signature of humanity. The idea that our presence on Earth will leave a marker in the geological record. A layer that future geologists, if there are any, will be able to identify and date as the time of humans. What will go into this layer? Fossil remains, of course. Bones of humans, domestic animals, perhaps even traces of our buildings if something very durable survives. But mostly it will be chemical and isotopic anomalies. A spike in carbon dioxide, the presence of plastic particles, radioactive isotopes from nuclear tests, elevated concentrations of metals and other pollutants. Some scientists have proposed calling our epoch the Anthropocene, the age of humans, a geological epoch defined by our impact on the planet. This would be the first time in Earth's history that a geological epoch was named after a biological species. But here's an interesting question. If there was another civilization in the past, would it leave a similar layer? Would there be a dinosaur scene or a Silurian scene, or whatever we'd call it? And if there was, would we recognize it? Maybe not, because we're not looking for it. When geologists study ancient rock layers, they look for natural processes. They interpret what they see through the lens of natural phenomena: volcanism, tectonics, climatic cycles. The idea that some anomalies might be the result of an ancient civilization's activity isn't even considered because it's deemed incredibly unlikely. And that's possibly correct. The scientific method requires that we start with the simplest explanations and move to more complex ones only if the simple ones don't work. And usually, simple explanations work. A strange layer in rock usually has a geological explanation. An unusual concentration of an element is usually the result of a natural process, but usually doesn't mean always. And if we automatically dismiss the possibility of artificial origin, we might miss something important. Not because it's likely, but because if it were true, it would change our entire understanding of the history of life on Earth. So, maybe it's worth at least keeping an open mind. Looking at anomalies not only as puzzles requiring geological explanation, but as possible, very improbable but possible, indications of something more unusual. Let's talk about mass extinctions. They've happened again and again in Earth's history, as if the planet periodically hits a reset button, erasing most of life and allowing what remains to start over. The most famous extinction occurred 66 million years ago. An asteroid the size of a mountain slammed into what is now the Yucatan Peninsula in Mexico. The impact energy was equivalent to billions of nuclear bombs. The shockwave rolled across the planet. Chunks of molten rock were ejected into the atmosphere. Some reached space and then fell back, creating a rain of fire across the world. Fires engulfed continents. Smoke and ash blocked the sun for months, maybe years. Temperature plummeted. Photosynthesis stopped. Plants died. The herbivores that fed on them died. The predators that hunted the herbivores died. Food chains collapsed worldwide. Dinosaurs, which had ruled the planet for more than 150 million years, vanished. Not all at once. Some species perhaps survived for years or even decades after the impact, but ultimately, one by one, they disappeared. By the end, only the smallest, most adaptable creatures survived. Mammals no bigger than rats, birds, some reptiles, and in the oceans, fish, sharks, some species that could feed on detritus and survive in dark, cold water. But this wasn't the worst extinction. Not close. 252 million years ago, something far more catastrophic occurred. This is called the Permian-Triassic extinction, or sometimes simply the Great Dying. And the name is earned. 96% of all marine species died out, 70% of terrestrial vertebrates. The only known mass extinction of insects. When it ended, the planet was nearly empty. Ecosystems had collapsed so completely that it took millions of years for life to recover to previous levels of diversity. What caused this? Scientists still debate the details, but the basic picture is clear. Massive volcanic activity in Siberia, called the Siberian Traps, erupted lava and gases for nearly 1 million years. Carbon dioxide and other greenhouse gases filled the atmosphere. Temperature rose. Oceans warmed and became acidic. Oxygen in the water became depleted. Marine life suffocated. On land, temperatures became unbearable. In the tropics, it may have been too hot for animals to survive. Acid rain destroyed vegetation. Ecosystems collapsed one after another like dominoes. And here's what's interesting. This extinction wasn't an instantaneous blow like the asteroid. It was a slow collapse, stretched over hundreds of thousands of years. Species disappeared in waves. Periods of crisis alternated with brief recoveries that were then followed by new crises. It was an agonizingly slow death of the biosphere. Now imagine a civilization existing during such an event. Not necessarily human, something else. They see their world slowly falling apart. Temperatures rising year after year, crops failing, oceans that once fed them becoming dead zones, water sources drying up or becoming polluted. They try to adapt, of course. They migrate to cooler regions, to the poles, to the mountains. They change their way of life, search for new food sources. Maybe they even understand what's happening if their science is advanced enough. Maybe they even try to do something about it. But ultimately, it's too much. The planet is changing too fast, too dramatically. Even an intelligent species with technology can't survive when the biosphere itself is collapsing. They die. Maybe not all at once. Maybe the last populations cling to life in refuges, caves, oases, places where conditions are still tolerable. But eventually, even they disappear. And when the crisis finally ends, when the volcanoes quiet and climate begins to stabilize, the world is empty, desolate, ready for a new chapter of evolution. But from the civilization that was here, nothing remains. Their cities destroyed by volcanic activity, buried under layers of ash. Their bodies decomposed, their technology rusted and crumbled. After a few million years, new life covers the planet, and nobody knows they were once here. This isn't just speculation for speculation's sake. This is a pattern we see again and again. Mass extinction, then recovery, then a new era of life. It's happened at least 5 times on a major scale and many times on a smaller scale. Each time it was an opportunity for a new beginning, but also an end to everything that came before. And here's the question worth asking. If an intelligent species existed before one of these extinctions, how would we know? The very event that killed them would also bury their traces. Layers of volcanic ash, deposits from floods, new geological formations. All of this would cover what remained of them. By the time future geologists studied those rock layers, all they would see is the extinction. Mass loss of species, changes in climate, geological disturbances. They wouldn't look for signs of civilization because why would they? The mass extinction is fully explained by natural processes. But maybe, just maybe, in some cases there was something else. A civilization caught by catastrophe it couldn't control. Or more disturbingly, a catastrophe it caused itself. Because here's another possibility we must consider. What if some mass extinctions weren't entirely natural? What if an intelligent species, reaching a high enough level of technology, could change its planet so dramatically that it caused its own extinction, and the extinction of most other species? We know this is possible because we're doing it right now. Our burning of fossil fuels is changing the climate. Our pollution is poisoning ecosystems. Our activity has already caused what some scientists call the 6th mass extinction. The ongoing loss of species at a rate that rivals the great extinctions of the past. If we don't change course, we could create conditions that ultimately make the planet uninhabitable for human life. And if we disappear, taking most of the biosphere with us, what will future geologists see? They'll see a mass extinction, sharp climate change, a layer with unusual chemical properties. But will they know it was a civilization that did this to itself? Or will they think it was just another natural catastrophe? This is a disturbing thought. But it also shows why it's so hard to find evidence of ancient civilizations. If they existed, and if they disappeared in a mass extinction, their signature would be indistinguishable from the signature of the extinction itself. Geology, climatology, paleontology, all the sciences we use to study the past would interpret the evidence as a natural phenomenon because, well, most of it would be natural. Only very careful, very purposeful analysis might detect subtle anomalies that hint at something else. And even then, without direct artifacts to confirm it, it would always remain speculative. But let's step back from catastrophes and think about something else. Time. The incredible amount of time Earth has had to experiment with life. 4.5 billion years. Let's break this down into more comprehensible chunks. The first 500 million years is a period of intense bombardment when the planet was forming and being hit by asteroids. Life couldn't exist in these conditions. But about 4 billion years ago, conditions stabilized enough for life to appear. The first 3 billion years, life was simple. Bacteria, archaea, eventually more complex single-celled organisms. Slow, incredibly slow evolution. But it was happening. Species appeared, adapted, disappeared. Ecosystems developed. Photosynthesis appeared, changing the atmosphere, filling it with oxygen. Then, about 600 million years ago, everything accelerated. Multicellular life exploded with diversity. Over the next 500 million years, all the major animal groups we know today appeared, plus many others that went extinct, leaving no descendants. 500 million years. That's an enormous span of time. During these 500 million years, life colonized land, evolved in every imaginable direction, survived several mass extinctions, each time recovering and continuing to experiment. During this time, different groups of animals dominated in different periods. First fish in the oceans, then amphibians on land, then reptiles, then dinosaurs for an incredibly long period, then mammals, and finally, in the very last moment, primates, hominids, humans. Each of these groups had hundreds of millions of years to evolve. Each produced thousands of species, some of which were very complex. And in each group, there was opportunity for developing higher intelligence, if evolutionary pressure favored it. Dinosaurs had 150 million years. Some of them developed complex social behavior. Some showed signs of parental care, built nests, defended their territory. Some, like the previously mentioned Troodon, had relatively large brains. Give evolution another 10 million years, another 20, and who knows what might have developed. Dinosaurs were successful for so long precisely because they were well adapted. But successful adaptation to a stable environment doesn't necessarily lead to intelligence development. Intelligence develops when there's pressure to solve problems, to adapt to changing or complex conditions. Maybe somewhere, in some branch of dinosaur evolution, in some period of their long reign, such pressure appeared. Maybe climate change forced some species to adapt faster. Maybe competition between groups became more intense, favoring smarter individuals. Maybe some ecological niche opened up that required problem-oriented thinking. And maybe, just maybe, one species made the leap. Not immediately to civilization, of course. Evolution doesn't work that way. But to tool use, to social structures, to transmission of knowledge from generation to generation, to the beginning of what we might call culture. This sounds like fantasy, and perhaps it is. But statistically, given the enormous amount of time and the enormous diversity of life, it seems almost strange that this happened only once. That of all the billions of species that ever lived, only one, ours, developed technological civilization. Maybe we're not the only ones. Maybe we're just the latest. There's one argument against the existence of ancient civilizations that seems convincing at first glance. It's the argument from silence. If they existed, we would have found something. We dig up the earth constantly for construction, mining, scientific research. We've drilled ice sheets, taken samples from the ocean floor, studied rocks from all continents. And we found nothing that definitively points to a civilization before us. This is true. We haven't found anything. But absence of evidence is not evidence of absence, especially when we're talking about timescales of hundreds of millions of years. Let's think about how much of Earth we've actually explored. The planet's surface is huge, about 510 million square kilometers. Of this, only 29% is land. The rest is ocean, most of which hasn't been explored in detail. On land, large areas are still wild, inaccessible, never studied from a scientific perspective. But even if we limit ourselves to areas that have been studied, we're only looking at the surface. Literally. Archaeological excavations typically go down a few meters, rarely more than 10 or 20. Geological studies can go deeper, but they focus on specific formations, specific time periods. A layer of rock dating to, say, 100 million years ago might be buried at a depth of hundreds of meters or even kilometers, depending on the geological history of the region. To get samples from this layer, you need to either find a place where it's exposed at the surface, which is rare, or drill, which is expensive and usually done only for specific purposes like searching for oil. So really, we've explored only a tiny fraction of the possible places where traces of an ancient civilization might be. It's like searching for something lost in a huge city, but only looking in a few buildings, and only on the first floor. You didn't find it, but does that mean the lost thing doesn't exist? Moreover, we don't know exactly what to look for. If traces have survived, they won't look like ruins of ancient Rome or Egyptian pyramids. They'll be something completely different. Oddities in geological layers, unusual mineral formations, anomalous chemical signatures. And if a geologist isn't specifically looking for signs of ancient civilization, and why would they be? They might see these oddities and simply note them as geological anomalies. Worthy of study perhaps, but not as evidence of something revolutionary. There's another aspect of this puzzle worth discussing: the very nature of intelligence and civilization. We think about them in very specific ways based on our own experience. But what if civilization can look completely different? Our civilization is built on certain principles. We're sedentary, building permanent settlements. We're agricultural, growing food. We're expansive, constantly expanding, seizing new territories, exploiting new resources. We're technological, creating tools, machines, structures from metal and stone. But this is only one path, one way of organizing intelligent society. Evolution could have created completely different paths. Imagine a nomadic civilization, a species that constantly migrates, following seasonal resources, never staying in one place long enough to build permanent structures. They could still have complex culture, language, even technology. But technology that's portable, light, perhaps made from materials that don't preserve: wood, leather, bone. Such a civilization wouldn't leave cities for us to find, wouldn't leave roads, perhaps wouldn't leave almost anything except the bones of the species itself. And if we found those bones, we'd simply classify them as another extinct species, not understanding they were intelligent. Or imagine a symbiotic civilization, a species that developed relationships with other organisms, plants, fungi, bacteria, using them as living tools. Instead of forging metal, they grew trees into specific shapes. Instead of chemical factories, they cultivated microorganisms that produced the substances they needed. Instead of building from stone and concrete, they used bioengineering. Such a civilization would be almost invisible in the geological record. Their technology would decompose just like any organic matter. The only trace might be unusual distribution of certain plant or animal species they cultivated. But after millions of years, even that would be indistinguishable. Or take an oceanic civilization we mentioned earlier. Dolphins and whales already demonstrate remarkable intelligence. They have complex social structures, communicate using sounds. Some species even use simple tools. What if in the past some oceanic species went further? In the ocean, it's impossible to light fire, which means the entire path of development through metallurgy, the Bronze Age, the Iron Age, would be impossible. But there are other paths to complex technology. Acoustics, for instance, using sound for navigation, communication, even for manipulating the environment. Bioluminescence for lighting. Currents and temperature gradients as energy sources. Such a civilization wouldn't build in our understanding of the word. Their cities might simply be gathering places, marked perhaps by arrangement of stones or cultivation of certain coral species. Their technology would be adaptation of natural processes rather than creation of artificial structures. And if such a civilization existed in an ocean that later disappeared or changed due to tectonic processes, which often happens on scales of millions of years, any evidence would be destroyed by subduction or buried under kilometers of new sediment. The point is, we're looking for civilization that looks like ours. Cities, roads, metals, plastic. But civilization doesn't have to look that way. It can take forms we can't even imagine. based on our limited experience of one type of intelligent life on one planet. This makes the search even more difficult. It's not enough to look for familiar signs. One needs to be open to the unfamiliar, to oddities that don't fit expected categories. One needs to ask not where are the cities, but what would be the equivalent of cities for a completely different type of civilization? And honestly, we don't know the answer to that question. We don't even know if it's the right question. Night deepens. Temperature drops. You pull the blanket higher, feeling its warmth, its comforting weight. Somewhere far away, a dog barks. The sound carries in the silence. Then, silence again. In this silence, it's easy to feel connection with the past. Not the recent past, not your parents or grandparents, but the deep past, with the planet itself. You're lying on Earth that existed long before you and will exist long after. Earth that has seen the rise and fall of countless life forms. And maybe, just maybe, it has seen the rise and fall of other civilizations too. Maybe the rocks beneath you hold secrets we'll never uncover. Maybe the story is much richer, much more complex than we think. But even if we never know for sure, the question itself is valuable. It makes us think differently about time, about life, about our place in the universe. It makes us humbler. And at the same time, it fills us with a sense of wonder. Because if they existed, these other civilizations in the deep past, then intelligence isn't unique to us. It's something the universe does, something that arises naturally under the right conditions. And if that's true, then we're part of a broader pattern, a deeper process. And if they didn't exist, if we really are the first and only, then we're even more special. The only time in 4.5 billion years that matter organized itself into consciousness that can understand itself. The only time the universe opened its eyes and looked at itself. Either way, it's something remarkable. Either way, it makes our lives meaningful. Let's talk about one more aspect often overlooked: cultural memory. The myths and legends humanity has told itself for millennia. Nearly every culture on Earth has stories about previous ages, about worlds that existed before ours. In Greek mythology, there were the Golden, Silver, Bronze Ages, and the Age of Heroes before our time. Each age ended in catastrophe, and a new one began anew. In Hindu tradition, time is cyclical, passing through enormous periods called yugas. We're now in the Kali Yuga, the age of darkness and decline. But before it were other yugas: Dvapara Yuga, Treta Yuga, Satya Yuga. Each previous epoch was better, more enlightened. And after Kali Yuga, the cycle will begin again, returning to a golden age. North American indigenous peoples told stories of several worlds that were created and destroyed before the current one. The Hopi people, for instance, speak of 4 worlds. 3 were destroyed due to people's wrongdoing, and we live in the 4th. The Aztecs believed in 5 suns, 5 successive epochs of creation. Each sun represented a world populated by different beings. The 4 previous suns were destroyed by various catastrophes: jaguars, hurricanes, rain of fire, flood. We live under the 5th sun, which, according to prophecy, will also end someday. In Sumerian mythology, one of the oldest written traditions, it spoke of kings who ruled before the flood. Kings who lived tens of thousands of years. After the flood came new kings with more human lifespans. This might be just a mythological way of saying there was a time before, radically different from the time after. Plato wrote about Atlantis, an advanced civilization that existed 9,000 years before his time and was destroyed by cataclysm in one day and night. Most scholars consider this a moral parable rather than historical account. But it's interesting that similar stories of lost civilizations appear in various cultures around the world. What should we make of these myths? The scientific approach tells us not to take them literally. They're full of supernatural elements, gods and monsters, magic and miracles. They reflect cultural values and fears of the societies that created them, rather than accurate historical records. But there's another way to look at them. Maybe they preserve some distant memory of real events, transformed by multiple retellings into mythical form. Memory of climatic catastrophes, of mass extinctions, of times when the world was radically different. Or, more intriguingly, maybe they preserve something deeper. Not memory, but intuition. A sense that people have always had. That the world is older than us. That other things were here before. That we're not the first. This sense might just be projection of our own mortality onto the world. We know we're born and die, so we imagine worlds are also born and die. We see ruins of ancient civilizations and extrapolate the idea of even more ancient, even more lost civilizations. But maybe this sense points to something real, to a pattern in nature that we subconsciously recognize. Cyclicity, rise and fall, creation and destruction. These are fundamental processes in the universe, from the lives of stars to ecosystems, from geological cycles to the evolution of species. So why not civilizations? Why should we be the only one, the unrepeatable event in the planet's history, rather than part of a cycle that repeated before and might repeat again? The myths don't give us evidence, but they give us perspective. They remind us that humans have always asked these questions, always felt there's more to the world's story than we can see or know. And maybe there's wisdom in that. Not wisdom in the specific details of myths, the gods and heroes, the numbers and names, but in the core message. Be humble. The world is bigger and older than you can comprehend. Just because you don't know something doesn't mean it isn't real. Now let's step back and look at the whole picture again. We've talked about deep time, about geological processes, about mass extinctions, about the difficulty of preserving evidence. We've talked about different forms civilization might take, and about myths that hint at the cyclical nature of history. All of this leads to one central point. We can't know for sure. And that's okay. Science isn't always about knowing. Sometimes it's about understanding the limits of our knowledge. There are questions we can answer. How old is Earth? 4.5 billion years with a small margin of error. How did life evolve? Through natural selection acting on random mutations over enormous periods of time. When did humans appear? About 300,000 years ago in Africa. These are things we know with high degree of confidence based on extensive evidence from multiple independent sources. But there are other questions we can't answer. Is life on Earth unique, or is it common in the universe? We don't know. Is the emergence of intelligence inevitable given evolution enough time, or is it an incredibly rare event? We don't know. Did other civilizations exist on Earth before us? We don't know. And this last question may be impossible to answer definitively. We can say there's no obvious evidence. We can say it seems unlikely based on what we know about evolution and geology. But we can't say with absolute certainty that it never happened. Because absence of evidence, in a case where evidence would be unlikely to survive anyway, doesn't tell us much. It's like looking for keys only under the streetlight, because that's where the light is. Even if you lost them somewhere in the darkness, you might not find them under the light. But that doesn't mean they're not somewhere out there in the shadows. So we're left with uncertainty. For some, this is frustrating. We want answers, certainty, closure. But for others, and I hope for you, this uncertainty is a gift. It means the world is still full of mysteries, that there are questions the next generation can explore, that we don't know everything, and that's okay. That's good. It means there's always more to learn, more to discover, more to wonder about. And in that wonder, there's something deeply human. The ability to look at the world and ask, what if? This is what makes us intelligent. This is what drives science, art, philosophy, curiosity, the desire to understand. Maybe someday we'll find evidence of an ancient civilization, an undeniable artifact, a chemical signature that can't be explained otherwise, a structure that's clearly artificial. That would change everything. It would rewrite our history, our understanding of life on Earth. Or maybe we'll never find anything. Maybe the question will remain open forever, and we'll continue asking, wondering, imagining. Either way, the very process of asking is valuable. It expands our minds. It makes us think in scales of time and space much larger than our daily lives. It connects us with the deep history of our planet, and perhaps with others who might have asked the same questions in the past. There's one thought experiment that might help clarify this entire discussion. Imagine you're a geologist living 100 million years in the future. Humanity has long disappeared. Maybe a new intelligent species has evolved, descendants of raccoons perhaps, or octopuses, or something that doesn't even exist now. This future geologist studies Earth's history, takes rock samples, analyzes chemical composition, studies fossils, builds a picture of how the planet changed over billions of years, and at some point reaches a layer dating to approximately our time, the beginning of the 21st century by old reckoning. What will they see? Will it be obvious that a civilization existed here? It depends on how carefully they look and what they're looking for. If they're just doing standard analysis, they'll notice several oddities. A sudden spike in certain carbon isotopes, unusual concentrations of some metals and rare earth elements, the presence of synthetic compounds not found in nature. But will they interpret this as evidence of civilization? Or will they find natural explanations? This was a period of intense volcanic activity, they might think, or maybe an asteroid impact ejected unusual materials into the atmosphere. If they really dig deep, if they're very thorough, they might find more convincing evidence. Microscopic plastic particles embedded in sediment layers, radioactive isotopes with half-lives and ratios that don't match natural sources. Maybe, if they're very lucky, a fragment of glass or ceramic preserved in a particularly protected environment. But even then, they'd need to make an intellectual leap. They'd need to consider the possibility that these oddities were the result of technological activity. And that's not a natural first conclusion. The natural first conclusion is to look for geological explanations, because geology is what they study. It's their frame of reference. Only if they specifically wonder, could there have been a civilization here? Only then would they begin interpreting evidence in that light. And even then, without direct artifacts, without buildings, without tools, without obvious structures, their colleagues might be skeptical. Interesting hypothesis, they'd say, but not enough evidence for such an extraordinary claim. And they'd be right in their skepticism. Extraordinary claims require extraordinary evidence. The idea that there was a civilization whose traces have almost entirely erased is an extraordinary claim. But here's the irony. This is exactly what happened. In this scenario, there was a civilization, ours. The future geologist stands on its remnants, studies its last traces. But they have no way to be completely certain. Now flip the experiment. We're geologists studying layers dating to tens or hundreds of millions of years ago. If there was a civilization then, we're in exactly the same position as the future geologist in our thought experiment. We see oddities, but we don't have the context to interpret them correctly. We don't have direct artifacts to confirm the hypothesis, so we explain the oddities through geological processes because that's the most obvious explanation. And we're probably right in most cases. But can we be right in all cases? Can we be absolutely certain that none of these anomalies is a trace of something more unusual? The honest answer is no, we can't. And this brings us to an important point about the nature of science. Science isn't about absolute certainty. It's about building the best explanations based on available evidence, while remaining open to new evidence that might change our understanding. Right now, based on everything we know, the most likely explanation is that we're the first technological civilization on Earth. There's no compelling evidence to the contrary. Evolutionary theory suggests that the emergence of this specific type of intelligence, our kind of intelligence that leads to technology, is a rare event. But most likely doesn't mean definitely true. It means the best explanation we have at the moment. And part of being a good scientist, or just a good thinker, is acknowledging the limits of our knowledge. We don't know everything. We never will know everything. And that's okay. In fact, it's beautiful because it means there's always more to learn. Let's now talk about something slightly different, but related. The Fermi paradox. This is a famous question in the search for extraterrestrial intelligence. If the universe is so huge and so old, why haven't we seen any evidence of other civilizations? Enrico Fermi, a physicist, asked this question in the early 1950s over lunch with colleagues. They were discussing UFOs and possibilities of alien life, and Fermi suddenly asked, "Where is everybody?" His argument was simple. In the Milky Way, there are hundreds of billions of stars. Many of them have planets. Some of these planets should be habitable. If even a tiny fraction of these habitable planets developed intelligent life, there should be millions of civilizations out there. And some of these civilizations should be older than us. Maybe much older. If they developed space travel technology, they could have colonized the galaxy in just a few million years, even traveling at fractions of light speed. So where are they? Why haven't we seen their ships, received their signals, found their artifacts? Many solutions to the Fermi paradox have been proposed. Maybe space travel is harder than we think. Maybe intelligent life is extremely rare. Maybe civilizations tend to destroy themselves soon after reaching technological level. Maybe they're here, but we don't recognize their presence. Maybe they're intentionally avoiding us. But there's another possible solution related to our discussion. Maybe civilizations don't last as long as we think. Maybe the period between developing detectable technology and a civilization's disappearance is very short by cosmic standards. Think about our own civilization. We've been broadcasting radio waves into space for only about 100 years. That's the window during which a distant civilization could detect us by intercepting our transmissions. 100 years out of 4.5 billion years of Earth's history. That's 0.0000022%. And how long will we continue broadcasting? Maybe a few hundred more years before we either destroy ourselves or transition to technologies that don't leak into space so much. Say 1,000 years of detectability total. That's still a tiny fraction of the planet's history. If this is typical, if civilizations are usually detectable only during a very short period of their existence, then the probability that two civilizations will be detectable simultaneously becomes very small. The galaxy might be full of planets that had civilizations, or will have civilizations. But the chance that two civilizations exist in detectable states at the same time is low. This is sometimes called the "they were here but not now" solution to the Fermi paradox. And it suggests something important. Civilizations are ephemeral. They come and go. The universe is full of ghosts of civilizations that no longer exist. And if this is true on a galactic scale, why wouldn't it be true on one planet? Why couldn't Earth have its own ghosts of civilizations? Species that achieved intelligence, maybe even technology, but disappeared long ago. This is speculative, of course, but it's consistent with patterns we see. Life is resilient, but individual species are fragile. Ecosystems can exist for millions of years, but they can also collapse. Stability is temporary. Change is the only constant. So, why not civilizations? Why should they be permanent when everything else is temporary? This leads us to reflect on our own future. If civilizations are ephemeral, if they tend to disappear either through their own fault or due to external catastrophes, what does this mean for us? It's not necessarily a pessimistic message, though it might seem so. Yes, it suggests we're not eternal, that our civilization with all its achievements might someday vanish like all civilizations before us, if there were any, and after us, if there will be any. But it's also a message about the importance of the present. If we're not eternal, then what we do now matters. Each generation shapes the future. determines whether civilization continues or ends. We can't rely on the inevitability of progress or assume everything will be fine automatically. We face serious challenges: climate change, resource depletion, potential for self-destruction through nuclear weapons or other technologies, social inequality and conflicts. These aren't abstract problems, they're real threats to our civilization's continuation. But we also have something previous civilizations, if there were any, might not have had: awareness. We know about the risks. We can see catastrophes approaching in slow motion. And that means we can make choices, change course, avoid the worst outcomes. It's not guaranteed. History is full of civilizations that collapsed despite warnings: the Maya, the Romans, Easter Island. There are many examples of societies that exhausted their resources or failed to adapt to changing conditions. But we're also more interconnected, more informed than any previous civilization in human history. We have global communication, science that can predict the future based on current trends, technology that can help us adapt. If we choose to use these tools wisely, if we choose to work together rather than against each other, we have a chance. Not a guarantee, but a chance. And that's all we ever have. The history of ancient civilizations, real or possible, teaches us humility. We're not invulnerable, we're not eternal, but it also teaches us resilience. Life continues. After each mass extinction, new species evolve, filling empty niches. After each collapse, new societies rise from the remnants of old ones. If our civilization falls, it won't be the end. Life will find a way. Maybe another species will eventually evolve to intelligence. Maybe millions of years after us, a new civilization will rise. And they'll ask the same questions we're asking. They'll look at rock layers and wonder what came before. And maybe they'll find our traces. Or maybe they won't. It's an uncomfortable thought for us as individuals or even as a species. We want to survive, to thrive, to continue. But from a broader perspective, from the viewpoint of the planet and life on it, it's simply part of the cycle. Rise and fall, creation and destruction, end and beginning. And in this cycle there's a certain beauty. Not because death is beautiful, it's not, but because it gives meaning to life. If everything lasted forever, nothing would matter. It's precisely the ephemerality that makes moments precious. You're lying here in this moment, on this night, in this life. And this is a unique moment in the universe's history. There has never before been exactly this arrangement of atoms, this pattern of consciousness, this particular thought in this particular mind. And there never will be again. In millions of years, the atoms that make up your body will be part of something else. Maybe rocks, maybe water, maybe other living beings. The energy that animates you will pass to other forms. The thoughts that fill your mind will disappear like ripples on a pond's surface. But right now, you're here, living, breathing, thinking, feeling. This is the precious gift of being alive, of being conscious. Of all the atoms in the universe, of all the possible configurations of matter, you exist. You're one of the few patterns of matter that can be aware of its own existence. Most of the universe is dead rocks and gas, cold void between stars. But not here. Here there's warmth, movement, life. Here there's thought and feeling. Here there's you. And as you lie here in darkness, preparing for sleep, let yourself feel gratitude for this. Not religious gratitude to some deity, just quiet acknowledgement of the incredible luck of existence. You might not have been. The chain of events that led to your birth was incredibly improbable. If any of your ancestors had died before reproducing, if any of countless random events had happened slightly differently, you wouldn't be here. But you are here. Against all odds, despite all improbability, you exist. And that's a miracle if you allow yourself to see it that way. The same is true for our species as a whole. We might not have emerged. If the asteroid hadn't killed the dinosaurs, if our primate ancestors hadn't survived at critical moments. If thousands of other things had happened differently, we wouldn't be here, but we are. We're here. And while we're here, we have the opportunity to experience the universe's beauty, to understand its laws, to create meaning and purpose. This isn't something to take for granted. This isn't something that will last forever. But while it lasts, it's real and precious. So let these thoughts calm you into sleep. Not thoughts of fear and oblivion, but thoughts of connection and meaning. You're part of an ancient story, a story that began billions of years ago and continues through you. Tomorrow the sun will rise again. The planet will continue spinning. Life will continue its dance of evolution and adaptation. And you'll be part of that, contributing your small piece to the ongoing story. Were there others before us? We may never know for certain, but the question itself has enriched you. It has expanded your mind, deepened your understanding of time and life. It has connected you with the deep history of the planet you live on. And in the end, maybe that's all we need. Not definitive answers, but the right questions. Not certainty, but wonder. Not knowing everything, but the humility to admit how much we don't know. The world is full of mysteries. Some we may solve, others might remain puzzles forever. And that's okay. That's good. It keeps us curious, keeps us searching, keeps us growing. Sleep peacefully under the ancient stars. Let the weight of deep time not press down on you, but rock you to sleep. Let the thought of lost civilizations not trouble your dreams, but fill them with wonder. You're lying on a planet 4.5 billion years old. Beneath you are layers of history deeper than any ocean. Above you are stars, some of which died long ago but whose light is still traveling to you through space. You're a moment between these vastnesses. Small, yes. Temporary, yes. But conscious, aware, capable of asking questions and wondering. And that makes you special. That makes this moment special. Not because it will last forever, but because it's here, now, real and alive. Were there others on Earth before humans? Perhaps yes, perhaps no. But you're here in this moment. And that's the only thing that can truly be known with certainty. The rest is mystery. Beautiful, deep, unsolvable mystery. And let that mystery lull you into deep, peaceful sleep. Good night. May your dreams be filled with ancient worlds and distant stars, lost civilizations, and future possibilities. And when you wake, the world will still be here, patiently waiting, keeping its secrets for another day. You're part of something ancient and ongoing. Remember that. Cherish it. Live well in the time given to you. And if someday, in the distant future, another species excavates the layers of our time and wonders who we were, let them find evidence of a species that loved, that created, that questioned, that cared. That would be enough. That would be all that's needed. But wait, there's more to consider before sleep takes you completely. Let's talk about what happens to information across deep time. We've spoken much about physical artifacts, about chemical traces, about geological anomalies. But civilizations aren't only physical objects. They're also about information, about knowledge, about culture. We transmit information in many ways. Orally through stories and songs, in writing through books and documents, visually through art and architecture, digitally through computers and networks. Each method has its lifespan. Oral tradition can last generations, even centuries. But over time, stories change. Details are lost. Facts become legends. Legends become myths. After a few thousand years, oral history becomes unrecognizable if it survives at all. Written documents are more durable, but only if materials preserve. Papyrus crumbles. Paper rots. Even stone with inscribed text eventually erodes. The Rosetta Stone, which helped us decipher Egyptian hieroglyphs, is only about 2,200 years old, and it's already significantly damaged. What will happen to it after 1,000,000 years? It will turn to dust. All the inscriptions, all the words, all the knowledge it contains will vanish. Digital information is even more fragile, paradoxically. We think of digital data as permanent, but it depends on very specific technologies for reading. Do you have a floppy disk from the 1980s? Good luck finding a computer that can read it. And in 100 years, when all our current computers have turned to scrap, who will be able to access information stored on our hard drives and servers? And this is just 100 years. After 1,000 years, all our digital information will be completely inaccessible. Physical media will decompose. Even if they somehow survive, there will be no technology to read them, no software to interpret the data. So, if an ancient civilization stored its knowledge in any form, carved in stone, written on materials, saved on some devices, all of it would have long disappeared. All their literature, their science, their history, their philosophy, all gone, erased by time. This is a deeply sad thought. Imagine everything humanity knows, everything we've created, Shakespeare and Newton, Mozart and Einstein, all the books, all the music, all the art, completely lost, forgotten, as if it never existed. But this is what would happen if we disappeared and enough time passed. And this is what would have happened to any civilization that existed in the deep past. Not only would their buildings and tools vanish, their ideas, their stories, their dreams, all gone, completely and forever. There's a certain horror in this, the work of lifetimes, the achievement of thousands of generations, the accumulated wisdom of an entire civilization, all reduced to zero, as if it never was. It makes you question the meaning of everything we do. If it will all ultimately be forgotten, what's the point? But there's another way to think about it. Meaning doesn't have to be about eternity. Maybe it's enough that something matters now, in this moment, for the people living it. A book doesn't need to last forever to be valuable to someone reading it. A song doesn't need to survive millennia to touch the heart of someone listening. We create meaning here and now, and that meaning is real even if it's temporary, maybe especially because it's temporary. Nevertheless, there's something in us that wants to last, that wants to be remembered. We build monuments, we write books, we try to leave a trace that will outlive us. This is a deep human need, the desire not to be forgotten, and maybe other civilizations, if they existed, felt the same. Maybe they too built monuments, trying to leave something behind. Maybe they knew their time was limited, and they wanted to say to the future, we were here, we existed, we mattered. If so, their message didn't reach us. Time erased it. But the very attempt, the very desire to be remembered is something we can understand, something that connects us across the chasm of millions of years. Let's talk about the oceans again, but from a different angle. We mentioned that oceans cover most of the planet and that they're poorly explored. But there's an even more interesting fact. Oceans change. Not just rise and fall with glacial cycles, which itself is dramatic, but they literally open and close over geological time. This is called the Wilson cycle, named after the geophysicist who described it. Here's how it works. A continent splits due to tectonic activity. Magma rises in the rift, creating new oceanic crust. The two halves of the continent slowly drift apart, and a new ocean grows between them. This is what's happening now with the Red Sea. Africa is splitting, and eventually, after millions of years, there will be a new ocean there. The new ocean expands over tens or hundreds of millions of years, growing larger and larger. The Atlantic Ocean is doing this now. It's getting wider by a few centimeters each year as the Americas move away from Europe and Africa. But then, eventually, the process reverses. The ocean begins closing. The continents on its edges start moving back toward each other. Oceanic crust subducts into subduction zones, melts back into the mantle. The ocean becomes smaller and smaller. Finally, the continents collide. The ocean disappears completely, replaced by a mountain range where the continents crumple into each other. The Himalayas are the result of such a collision, where India crashed into Asia, closing an ocean that was once between them. This cycle takes hundreds of millions of years, and it's happened many times in Earth's history. Supercontinents form when all continents come together. Then they break apart. Oceans open between the fragments. Then the fragments migrate and eventually gather back into a new configuration, closing old oceans and opening new ones. The last supercontinent was called Pangaea. It existed about 300 million years ago. All continents were connected in one massive landmass surrounded by a global ocean. Then, starting about 200 million years ago, Pangaea began breaking apart. The fragments slowly drifted into the configuration we see today. But this isn't the end of the story. Continents are still moving. In 50 million years, Africa will collide with Europe, closing the Mediterranean Sea. Australia will crash into Asia. In 250 million years, according to some predictions, all continents will gather again into a new supercontinent already named Pangaea Ultima. Now think about the implications for our question. If a civilization existed on the shores of an ocean that has since closed, all traces would be destroyed. The ocean floor they lived on would have been subducted into the mantle, melted, recycled. The continents that were once separated by that ocean are now merged, creating mountains where the ocean was. If you stand in the Himalayas, you're standing on a place that was once ocean floor. The rocks beneath your feet formed on the seafloor hundreds of millions of years ago. And if once upon a time creatures lived on the edge of that sea, if a civilization thrived there, all evidence would have been destroyed by the collision that created the mountains. This is another reason why it's so hard to find traces of ancient civilizations. Earth doesn't just erase its surface through erosion, it completely restructures itself. Oceans appear and disappear. Mountains rise where there were plains. Deserts form where there were forests. The entire landscape of the planet changes beyond recognition. If you could travel back in time 100 million years, you wouldn't recognize Earth. The continents would be in different places. The climate would be different. Flora and fauna would be completely alien. It would be a different planet. And if you went back even further, 200 million, 500 million years, it would become even more unrecognizable. Each period of geological time is a different world with its own geography, its own climate, its own inhabitants. In each of these worlds there was opportunity for the evolution of intelligence, and in each transition from one world to another, traces of what came before were mostly erased. We live on a planet with a short memory. It remembers the recent past reasonably well. The last few million years are recorded in relatively accessible rock layers and ice. But the further back you go, the hazier memory becomes. Details are lost. Entire epochs are represented only by thin layers of compressed sediment, and the most distant past is almost completely erased, remelted, and recycled by tectonic processes. If Earth were like a book, it would be a book where pages are constantly being rewritten. Old stories are erased to make room for new ones. By the time you get to the beginning, only a few words remain from the original text. And somewhere in those erased pages might be stories we'll never read. Stories about others who were here before us. There's a concept in philosophy called the Overton window. The range of ideas considered acceptable for discussion in society at a given time. Ideas inside the window are seen as reasonable, worthy of debate. Ideas outside the window are seen as radical, absurd, not worth serious consideration. The window can shift over time. Ideas that were once unthinkable can become acceptable. And conversely, ideas that were once mainstream can become marginal. Right now, the idea of ancient non-human civilizations on Earth is outside the Overton window for mainstream science. It's seen as pseudoscience, as something only conspiracy theorists and enthusiasts believe. A serious scientist who proposes it risks their reputation. But should it be this way? The Silurian hypothesis showed that the question can be formulated scientifically. It's not about belief, it's about evidence, or lack thereof, and how we interpret what we find. Maybe it's time to shift the window slightly, not to the point where we assume ancient civilizations existed without evidence, but to the point where we acknowledge it's a possible question worthy of investigation. Because even if the answer is ultimately no, we find no evidence, the process of searching will teach us things. It will force us to develop new methods, ask new questions, think about Earth and its history in new ways. And if by some incredible stroke of luck the answer turns out to be yes, there's something here that can't be explained by natural processes, well, that would change everything. It would be one of the greatest discoveries in human history. Is it worth the risk of looking foolish? Is it worth the career risk for young scientists who might want to explore this? Perhaps not on an individual level, but from society's perspective, from the perspective of science as a whole, yes, it's probably worth it. We progress by being open to new ideas, even ideas that seem unlikely. We progress by asking questions others consider foolish. History of science is full of examples. Continental drift was ridiculed when first proposed. The idea that Earth orbits the sun was heresy. Quantum mechanics seemed absurd even to its founders. But evidence eventually won, and what seemed absurd became accepted truth. Could this happen with the idea of ancient civilizations? Honestly, probably not. The evidence really isn't there right now. But probably not isn't definitely not. And in science, we should follow evidence wherever it leads, even if it leads to unexpected places. The stars above you slowly rotate. Earth spins, carrying you through the night. Somewhere on the other side of the planet, the sun is rising, starting a new day for people you'll never meet. Life continues in its endless cycle, and in this cycle, you're a small part, a temporary pattern of organized matter and energy. But you're also part of something larger, a line of consciousness stretching back through millions of years of ancestors, through countless generations of beings who struggled and survived so you could be here. And maybe, if you think broadly enough, you're part of an even wider line. Not just the human line, but the line of intelligence as a whole. If intelligence appeared before in other forms, if it will appear again in the future in forms we can't imagine, we're all part of the same phenomenon. The universe trying to understand itself. This is a grand thought, maybe too grand for late night. But there's something comforting in it. The idea that we're not alone in time, that others perhaps struggled with the same questions we struggle with, that we're part of a pattern larger than we can see. It makes our small lives meaningful, not despite their brevity, but because of it. We're moments in a long story, but moments matter. They make up the story. Let's talk about what happens to the very concept of civilization when we apply scales of deep time to it. We're used to thinking of civilization as something grand, permanent, important. Egypt existed 3,000 years, Rome 1,000. That seems like eternity in human terms, but in geological terms, 3,000 years is less than the blink of an eye. It's like one snowflake in a blizzard, one drop in an ocean. If all of Earth's history is a football field from one goal line to the other, then 3,000 years of Egyptian civilization is the thickness of a human hair at the very end of the field. This perspective does something strange to our sense of importance. On one hand, it's humbling. Everything we've built, everything we're proud of, on a cosmic scale is practically nothing. We exist in a tiny slice of time on a small planet, in an ordinary star system, in the arm of an ordinary galaxy, among billions of galaxies. But on the other hand, it makes each moment more precious. If our time is so short, if we're so ephemeral, then what we do here and now takes on special significance. Not because it will be remembered forever, it won't be, but because it's all we have. Imagine a butterfly that lives only one day. For it, that day is all of life, all the universe. Does it matter that it will live only 24 hours? To the butterfly, it doesn't matter. It lives fully, intensely in its time. We're like those butterflies. Only our day lasts a few thousand years instead of 24 hours. But the principle is the same. Our time is short, but it's ours. And what we do with it matters to us, here, now. If other civilizations existed before us, they too had their days. Maybe their days were longer than ours, maybe shorter. But each day mattered to those who lived it. They loved, created, struggled, dreamed. And then their day ended, and the night of oblivion came. Our day is still ongoing. The sun still shines on our civilization. But someday, inevitably, our sunset will come too. This isn't cause for despair. It's simply the reality of temporal existence. What should we do with this knowledge? Some might say nothing matters if everything will ultimately be forgotten. Why try? Why build? Why create if it will all be erased? But this is a nihilistic answer, and it misses the point. Things matter not because they're eternal. They matter because they're real in the moment of their existence. A sunset is beautiful even if it lasts only a few minutes. A song is moving even if it ends. Life is meaningful even if it's finite. In fact, one could argue that it's precisely finitude that gives things their value. If we had infinite time, nothing would be urgent. Nothing would be special. It's because time is limited that each moment is precious. So if we live on a planet where civilizations might have risen and fallen before us, if we're part of a long cycle of emergence and disappearance, that doesn't make us less meaningful. It simply places us in a broader context. We're not the pinnacle and end of history. We're a chapter in an ongoing book. And maybe that's a healthier way to think about ourselves. Not as the final achievement of evolution, not as the goal of all Earth's history, but as one iteration in an ongoing process. Nature's experiment in creating intelligence and consciousness. This experiment may continue after us. If we disappear through our own foolishness, through natural catastrophe, through bad luck, life will continue. It always continues. And maybe after millions of years, another branch of evolution will create another form of intelligence, another civilization, and they'll look at the stars as we do now and wonder, are we the first, or were there others before us? And they won't find our traces just as we haven't found traces of those who possibly came before us. It's a cycle, not a vicious circle, but a spiral. Each iteration perhaps slightly different, slightly more complex, learning from past mistakes even without knowing those mistakes were made. Or maybe not. Maybe each civilization makes the same mistakes, faces the same problems, fails for the same reasons. Without memory of the past, we're doomed to repeat it. This is one reason why history matters. Not just human history of the last few thousand years, but deep history. The history of life on Earth. The history of the planet itself. The more we understand about what came before, the better we can navigate the present and plan for the future. And if we ever find evidence of an ancient civilization, it would be an incredibly valuable lesson. We could study what they did right, what they did wrong. We could see how they dealt with challenges we now face. We could learn from their successes and their failures. But even without such concrete evidence, the very question is valuable. It forces us to think in longer timescales. It reminds us that our actions have consequences extending beyond our own lives, beyond our civilization. When we burn fossil fuels and change the atmosphere, we're leaving a trace that will last millions of years. When we spread plastic across the planet, we're creating a layer in the geological record. When we cause species extinctions, we're changing the course of evolution. We're leaving a legacy. Not monuments or books, those will vanish, but a deeper legacy written in the very fabric of the planet. Future geologists, if there are any, will read this record. And what will they think of us? Will they see a civilization that lived in harmony with its planet? Or will they see a species that recklessly exploited resources, polluted the environment, and ultimately destroyed the conditions of its own existence? This is still undecided. We're still writing this story. The legacy we leave depends on choices we make now in these critical decades. And this brings us to another thought. Maybe if ancient civilizations existed, they faced the same choices. Maybe some made wise choices and lived long, leaving light traces. Maybe others made poor choices and self-destructed, leaving chaotic signatures of catastrophe in the geological record. We look at mass extinctions of the past and see natural catastrophes. But what if some of them weren't entirely natural? What if an intelligent species, reaching sufficient power, could change its planet so dramatically that it caused its own extinction and the extinction of countless other species? This isn't mere speculation. We're doing it right now. The sixth mass extinction happening currently is caused primarily by human activity. We're changing the climate, destroying habitats, polluting ecosystems. Species are vanishing at an alarming rate. If we don't change course, this could become a full-scale mass extinction comparable to the great extinctions of the past. And when future geologists study this layer, they'll see a sharp loss of biodiversity, changes in atmospheric chemistry, unusual concentrations of certain elements. Will they know it was a civilization that did this? Or will they attribute it to natural processes as we do with ancient extinctions? It's a troubling thought, but also motivating. We have the power to change this story. We can choose a different path. We can decide to live sustainably, protect biodiversity, minimize our footprint. It's not easy. It requires sacrifices, compromises, changes in how we live, but it's possible. And if we do it, we'll leave a different legacy. Not a trace of destruction, but evidence of a species that learned to live in balance with its planet. And maybe if future intelligent beings ever discover our traces, they'll see this. They'll see a civilization that faced a crisis and found a way to survive. That would be a legacy worth being proud of. The night deepens around you. The sounds of the world fade. Only the quiet breath of wind, the distant rustle of leaves, occasionally the cry of a night bird. In this silence, it's easy to feel connection with the past. The atoms in your body are older than Earth. They were created in the hearts of ancient stars that exploded billions of years ago. The carbon in your cells, the calcium in your bones, the iron in your blood, all of it, stardust. Literally, you're made of the universe. And the universe is aware of itself through you, your thoughts, your consciousness. This is the cosmos experiencing itself, understanding itself. And if this is true for you, it was true for all conscious beings that ever lived. Every animal that experienced a moment of awareness, every intelligent being that looked at the stars and wondered. We're all part of the same process. The universe's experiment in creating complexity, in organizing matter into patterns that can think and feel and create meaning. This experiment began billions of years ago when the first molecules started copying themselves in ancient seas. It continued through countless generations of single-celled organisms. It blossomed in the Cambrian explosion when multicellular life suddenly diversified into thousands of forms. It survived mass extinctions. Each time it seemed the experiment might end, life found a way to continue. Survivors adapted, evolved, filled empty niches. And the experiment continued, becoming ever more complex. Eventually, it produced brains complex enough for self-awareness. Dolphins and elephants, ravens and octopuses, apes and humans. Each in their own way conscious, each experiencing the world through their unique perspective. And maybe along the way, there were other species with brains complex enough not just for consciousness, but for abstract thinking, for culture, for technology, species that built their own versions of civilization. If so, they too were part of the experiment, another attempt by the universe to understand itself. And if they failed, if they vanished, well, the experiment continued. It always continues. We're in that experiment now. We're the latest attempt as far as we know. And the question is, what will we do with it? Will we continue the experiment, or will we become another failed iteration? Another forgotten civilization buried under layers of future time? It depends on us, on the choices we make collectively as a species. And that's an enormous responsibility. But it's also an incredible opportunity. We have the chance to be the civilization that survives, that thrives, that maybe someday reaches the stars. We have the chance to know the universe, to truly understand it. We have the chance to create beauty and meaning on scales our ancestors couldn't even dream of. But it's not guaranteed. Nothing is guaranteed. History is full of unexpected turns, catastrophes nobody foresaw. We can do everything right and still fail through bad luck. An asteroid, a super eruption, a pandemic against which there's no defense. Or we can do everything wrong and doom ourselves through our own foolishness. History is also full of examples of that. Civilizations that destroyed themselves through war, through resource depletion, through failure to adapt to changing conditions. We don't know what our future will be. Nobody knows. But we can influence it. Our choices matter. What we do today shapes what will be tomorrow. And this is true not only for big choices, climate policy, international relations, technological development. It's true also for the small choices each of us makes every day. How we treat each other, how we care for the world around us, what we create, what we destroy, what stories we tell, what values we pass to the next generation. All of this matters. All of this is part of who we are as a civilization. And all of this together determines whether we'll survive or become another forgotten chapter in Earth's history. Sleep peacefully now. Let these thoughts not burden you, but comfort you. You're part of something ancient and ongoing, part of the universe's long experiment in creating consciousness. Tomorrow awaits with all its possibilities. Rest now. Dream of ancient worlds and future possibilities, of connections across time, of the preciousness of this moment. You are here. You are real. You are part of the story. And that, in itself, is enough. That is everything. Good night. Sleep well. The universe continues its ancient dance, and you dance with it, now and always.